All right, so this is day 3, and I believe this is really the last day of notes before we start the statistics project. Before I explain that, so this is called linear regression. This is by far the most important thing from the unit. It's what they ask the most questions about on the state EOC. And so here are all the directions. Again, linear regression is a method to find the line of best fit given a data set. But it actually gives you a specific equation. So instead of like, you know, if you have a scatter plot, and you know that your line should be like somewhere like that, right? But you don't actually know what the equation of the line is. And so to figure out what the equation of the line is for this time, for this unit, it will be okay if you use Desmos. So here are the steps on page 4 of how to walk through how to find the actual line of best fit using Desmos. And I'm going to go over all that in a second. But here's what you definitely need to know for Delta Math. If you don't know how to round, well, that's why I included it in the packet. Because Delta Math is going to be specific, and it's going to say something like round your coefficients to the nearest hundredth, which would be the second decimal place. Or it might say round your answer to the nearest tenth, which would be the first decimal place. Or it might say round to the nearest whole number, which would mean you look at the 1 here, and because there's a 0 next to it, you keep it at 51. Whole number would mean no decimals. If it was like 51.9 and it said round to the nearest whole number, that would be 52. Okay, so again, that has to do with the delta math. And then I go over like a full-blown example, but I'm going to do that in a second. So you can do it on your graphing calculator. It's just way harder to do it on the graphing calculator, and you're allowed to use Desmos on the EOC. So I'm going to show you the Desmos way. So here's what we got. Like I said before, a lot of these questions actually represent real data points. So this says the data in the table shows the average temperature in northern latitudes. So you got the latitude and you have the temperature. So let's just call the latitude X and the temperature Y. So what we're going to do is we're just going to plug this chart into Desmos. Again, X is latitude, Y is temperature. So open up Desmos, would look like this. And the very first thing you need to do is if you hit the plus sign. So by the way, this should be the Desmos graphing calculator, not the scientific one. But you need to hit the plus sign, and then you just click table. And so again, X is latitude. So if you're looking at your page, X would be 0, 10, 20, 30, 40, 50, 60, all the way to 80. And then Y is 79, 81, 79 again, 68, 58, 43, 28, 13, and 1. All right, so you type in your data points, and the thing is, you should actually see your data pop up. It should actually plot these points. And if you don't, if you just zoom out, well, there you go. So if you zoom out enough, you could actually see the scatter plot be created. So it looks like there's a negative correlation between the latitude and the temperature. So here's what we do. You have to know this formula. Okay, so I'm actually going to write it on the sheet of paper. And it's on here, is after you type in the data set, you type in this formula. You have to know this. If there's one equation that you should know for the EOC, it'd be this. It's Y1 with a little squiggly line, MX1 plus B. So like, I think in Spanish class, maybe that's like a tilde. I'm not sure. But that is what you type in below the chart. And so this button there is on your keyboard, And on my keyboard, at least, above the tab key, I have this and this. So if you hit shift this button, it should actually bring up that tilde. So let's type this in. I have my chart. I type in Y1. I literally just click 1 and it automatically makes it smaller. And I hit shift, that key, MX1 plus B. And you can see it plots the line of best fit. So let me do that one more time. And if that was too much, you could always click the keyboard and you could do Y equals, like using the keyboard. And if you hit ABC, here's that button. Oops, sorry, not Y equals. Y1 with this button, MX1, and then plus B. So this keyboard will do the same thing, or you could actually just do it without doing that keyboard. So you have a bunch of stuff here. First, it plots the line of best fit. It actually gives you the y-intercept, which is B, and it gives you the slope. It also gives you the correlation coefficient. So again, capital R squared is not something we have to know for this class, but lowercase r is the correlation coefficient. And because it's negative 0.969, that would mean that there is a strong negative correlation between latitude and temperature. So they're correlated, they're related strongly, but in a negative way. So as latitude increases, temperature decreases. That's what the negative correlation means. Okay, so going back to the question. What do we have to do? It says find the line of best fit. Well, you need two things to write an equation of a line. You need to know what the slope is, and you need to know what the y-intercept is. And this is why you have to know how to round, because on Delta Math, most likely it's going to say use your or round your coefficients to the nearest hundredth. So let's do that. Let's round to the nearest hundredth. So if I look at my Desmos here, m is equal to negative 1.07167. And b is equal to 92.866. Was that 3 sixes? 6667. Okay, so it's 3, 6, and a 7. So what I did is I just copied that down on my sheet. And now I want to round these to the nearest hundredth. So the hundredth is the second decimal place. So I'm going to underline the second decimal place. I'm going to look. Because that is a 1, because it's not 5 or greater than 5, it's going to stay negative 1.07. So my equation is going to be y equals negative 1.07 with an x, because that's my slope. Then I need an x next to my slope. And then my y-intercept is positive 92. But again, I have to round this one. This one's going to look a little different. Because next to the hundredth place is a 6, it's going to round up to 92.87. And that's my line of best fit. So I typed in the chart. I typed in y1 squiggly mx1 plus b. It told me what my m is. It told me what my b is. I plugged that in. I use that. And then it says estimate the average temperature for a city with a latitude of 48. So this is a totally different question. First thing is, can you find the line of best fit? That's part 1. Part 2 says, can you then use your equation to calculate the average temperature? Temperature we called y. So it's basically saying find y when x, because latitude represented x, when x is 48. And if you look, we don't have a latitude of 48, right? We have a latitude of 40, we have a latitude of 50. So I would believe that my answer should be in between these two, but I have to actually use the equation to get a value that is not on my charts. That is what linear regression is. It's basically you're using your equation to estimate data that you actually don't have data for. Like you're using your line of best fit to predict what the value would be. So for example, find y when x is 48. So we need to find y, but we now know that we should plug in 48 for x. So negative 1.07, I plug in 48 for x, and I add 92.87. Then all I do is I plug that into Desmos, and it should tell me the answer. Or you could plug it into your calculator. So you don't even have to include the y equals. You could just say negative 1.07, plugging in 48 for x, plus 92.87, and it's 41.51. Okay, so going back to my paper, it says estimate the temperature when a latitude is 48. So when the latitude is 48, we estimated, we predicted, we didn't actually have real data, but we predicted that the average temperature would be 41.58, and that's degrees Fahrenheit. So it makes sense because we have data for when the latitude is 40, temperature was 58. When the latitude was 50, the temperature was 43. So if the latitude is 48, which would be really close to 50, you're somewhere in between there, right? Which would be 41.5. All right, so let's try another one. So this one here, it says the data in the table shows the number of passengers and the number of suitcases on various airplanes. So again, these data tables, like they literally figured out, like if there was 75 passengers, they counted the suitcases. Like it's real data that they collected. And so let's say X is passengers and Y is suitcases. So what we first need to do is draw the line of best fit or find the line of best fit using Desmos. And then we have to estimate the number of suitcases on a flight carrying 250 people because we don't have the actual hard data for when there are 250 people. So we have to estimate it using our line of best fit. And that's why the line of best fit is so powerful. It's actually used in real life all over the place. Like they use it even at Yellowstone National Park. There's a geyser which like spits out water from the ground, and they found that it has a linear relationship. So what they do is they use linear regression to predict when it would go off again. So basically, tourists can schedule their entire day around this event because they use linear regression to predict when it's going to go off. They don't have that data yet because it's in the future, but they can predict down to like, the seconds of when this thing is going to go off so everyone can kind of gather around it and watch it go off. I'll put a video in the bio here. I don't know what it's called, the description, to show you that. It's just cool that it's used in real life. But anyways, passengers is X, suitcases is Y. So I'm going to create a new table. And I'm just going to totally exit out everything. I'm going to do plus table, and I'm going to type in my passengers: 75, 92, 115, 128, 143, 154, 178, and 200. And it's a lot of typing in, but again, it does most of the math for you. It's way easier than using the graphing calculator. So at this point, a lot of people usually complain that, man, we have to type in all this. Yeah, you do, but it ain't that bad. 310, 357, and 405. So step one is plot your data in a table, zoom out, Okay, it looks like it's definitely a positive relationship. I could see that. It's probably pretty strong. I mean, it looks like those dots are, they're not very spread out. So let's see what it is. Underneath my table, I do Y1. Again, I could bring up the keyboard if I need to. Hit ABC, little squiggly line. M, X. Again, you just click 1 and it appears. Plus B. Okay, so, and you can see the R value is 0.9974. So it's like super strong. There is a very strong relationship between the number of passengers and the number of suitcases. There's a strong positive relationship, which makes sense, right? The more passengers that you have on an airplane, the more suitcases that you're going to have. There's, as X increases, Y increases. That makes total sense. But again, I want to copy down my M value and I want to copy down my B value. I want to copy down just the full decimal and then we'll round later. So I'm going to go ahead and copy these down. Copy down my slope and my y-intercept. And then this is what it looked like on my paper. And then I'm going to round to the nearest hundredth. And so I look at my second decimal place, it's a 7, but next to that 7 is a 9, which means my slope would be 1.98. I round that 7 up. And then for my y-intercept, my second decimal place is a 6, but next to it is also a 6. So that would also round up to 7.97. So my y-intercept, they're both positive, so it's going to be positive 1.98x. Always remember your x next to your slope, plus 7.97. And that's your equation. That's your line of best fit. So now what we need to do is we need to estimate the number of suitcases on a flight. So suitcases is y. So now it's saying find y when you're carrying 250 people, when x equals 250. So you do the same thing that we did before. You do not have data for 250 people. You only have data for 200. So basically what you're saying is if this trend was to continue, if this same pattern was to continue, and you had 250 people, well, we could guess it's probably going to be over 405 suitcases. But what would it be, like a really specific guess? You're using the line of best fit to predict what it would be without actually having the data points. So everywhere we see an X, we plug in 250, and then all we do is we just take this, plug that into Desmos, and see what we get. So I'm going to do it below here. I'm going to do 1.98 in parentheses 250, and then plus 7.97. And my answer is 502.97. So 502.97. And it says when you're carrying 250 people, how many suitcases would you have? So like a rough estimate, sometimes it would just say like round to the nearest whole number. You just round up in this case. So you would have about 503 suitcases. And like I said, we knew that when there was 200 people, there was 405 suitcases. So when there was 250 people, we knew it was going to be, over 405 suitcases, and we got 503. So you're using the line of best fit to predict future values.